Hello and welcome to my first YouTube video. This is Cracking the Cryptic, Fog of War pack number 43. The rules are Fog of War, Killer, and Classic Sudoku. Without further ado, let us begin. And we will begin by coloring where all of these cages actually go to. We don't actually know how big the cages are because we are playing Fog of War, but we will color every time that we know that a cage goes somewhere. And in order to do that, we're gonna be looking at where the cages actually go to and where their borders are, as well as where the indication of what the cage sums up to is, because the indication is always in the top leftmost corner. So the free is just two cells long. The 12 also 2 cells long. Why? Because it cannot curl up, right? Because as we just said, the indication of what the cell sums up to must be in the top leftmost corner of the cage. There's a 6, at least 2 long. 19, at least 3 long. There's the 5, which is exactly 2 cells. The 9, at least 2. 21, at least 3. 4, which is exactly 2. 15, at least 2 cells, but doesn't go over here. Could possibly go over here. There's a 17, which is necessarily 2 cells long. And there's a 10, at least 2 cells. 14, and then 18, which is at least 3 cells. 13, let's make it orange. 7, at least 2 cells long. And there's 20, let's make it orange. There's the 8, at least 2 cells long. 22. Now these are a bit interesting because it goes down here, right? It cannot go to the right or it would intrude upon this thing. So let's color this thing as orange. No, let's make it yellow. So we know that the 22 cage cannot possibly fit in just 2 cells. So we must go to the left. And the 24 cage also cannot fit in just 2 cells, so it must go down. And this means that the 7 is bounded to just 2 cells. So, because the 7 is bounded, we can start slowly filling stuff in. This is either 6-1, 5-2, or 4-3. And 11 over here goes down like this. 16, we can make it orange. And 23, it can be green. All right, now we've finished coloring everything, and it's time to start filling in the possible values for these cages. So the free cage, obviously, it must have 1, 2. The 4 cage must have 1 free. The 5 cage, it's either 2 free or 4, 1. And now here comes the interesting part. The 6 cage, we said that it could be 3 cells long. However, if it was, then that would be 1 plus 2 plus 3. That's the only way to make it 3 cells long. However, that would have both 1 and the 3 somewhere here, which contradicts the fact that this row has 1 or 3 down here. So if 1 free is here, this will be empty. So this means that this must be 2 cells long and not 3, making this a 5-1 or a 4-2. All right, let's keep on. And this 12 here is only 2 cages long, as we said. So 9 free, 8-4, or 7-5. Now let's fill in everything else. We'll fill in all the possible values that all the other squares could have. And we will be using that to make deductions. I know that this isn't really standard notation. People don't like doing it this way. Oops. But I prefer it. And that is because it lets me see stuff in front of me that I can reason about. So instead of just reasoning while looking at empty space, I see the actual cells. It makes it easier for me. All right, this is a 1-2 pair. So that means that this cannot be a 1 or a 2, right? Since these two cells can only have 1 and 2 as inputs, and they have 2 values in them, that means that this must be 1 and 2 in them. So look at this, 4, 5. That means that over here we cannot possibly have 4 and 5, because if we did, that would force the other value to be 5. Like 4 here is a 5 here, so that would be a 9 and not a 6. And it's the same stuff here. If this was a free, it would be way higher than 5. So this cannot be a 3 or a 4 in order to sum up to 5. And that gives us another pair, another 1-2 pair. So this, oops, somehow, okay, so this cannot be a 1 or a 2. I'm doing this on my phone, and my controls are so small actually, so it's a bit difficult to click on everything. All right, so over here we have one free pair, which lets us clear this. Let me check, double check that I clicked correctly. So 1 and 3. All right. And this is 17. This sums up to 17. So since it's only 2 cells long, that must mean that this is 9 and 8. So 2, 4, 5, 6, 7. Cannot be here. So this is 8, 9. Perfect. 8, 9. Now take a look at this. This is a 10. Let's assume that this 10 is 3 cells long. Well, if it was, it is immediately obvious that it needs to have a 1 or a 3 in it, and it cannot have either because this row already has 1 and 3 in it. So that must mean that it is 2 cells long, and it cannot contain a 1 or a 3 or an 8 because of this. So it must be 4 and 6. So it cannot be 4, 5, or a 7. And over here, so 4 and 6. Perfect. Now let's take a look at this 15. This 15 cannot possibly contain a 4 here. Why? Well, first of all, we mentioned that it could only be be either 2 cells long or 3 cells long. We don't know which, but no matter which of the cases it is, 4 plus 5 is 9, and there is no 6 here to make it a 15, and 4 plus 7 is 11, and it cannot have a 4 here again, nor is there a 4. So this means that this cannot be a 4. Can it be a 5? Nope. 5 and 7 is 12, and there is no 3 over here. So cannot be a 5, cannot be a 7 for the same reason. And could it be a 9? Nope. 9 and 5, 14. There is no 1 here, and 9 and 7 is greater than 15. So it's either 6 or an 8. Let's keep going. Over here, we see that there's 1, 2, 3, 4, and there's a 7 cage. Let's assume that one of these values is a 1. Well, if it was, then this would be a 2, and this will be a free. So there will be no 1, 2, or free in the 7 cage, making the lowest possible value that it could take 4 and 5, making that a 9 and not a 7. So that's a contradiction. So there could be no one here. What about a 2? Well, if this was 2, this would be a 1 and 4. So there will be no 1, 2, and 4 here. In order to make a 7, you need one low value and one higher value, right? So the only low value we have is a 3. But the 3 lacks the 4 because the 4 is here. So it cannot make a 7. The lowest value it can make is an 8 with a 5 right here. So that means that a 2 also cannot be in any of these squares. Let's take a look at this, the 9. Let's assume that the 9 is 3 cages long. Well, we have a 1, 2 pair. That means that it can be 3 long. It must be 2 cells long. And that means that it cannot possibly have a 9 or an 8 or a 7. And now that creates something interesting. Let's assume that in one of these squares there is a 3 or a 4. If there was, that would make this pair match. So if this is a 3, then this is a 4. That means that this thing would sum up to 11. It would be a 5 and 6 and not a 9. And that's a contradiction. So these 4 cells are not allowed to be 3, 4. Let's keep going. This is the place where I want to introduce the fact that the hints are not really accurate for this puzzle. The hints are kind of forgetting the fact that this 21 right here could be either 3, 4, or 5 cells long. They only cover the cases where it's 4 or 5 cells long, but they don't consider the case where it's 3 cells long at all. And that is a really difficult case, which makes this puzzle much harder than what the official rating reflects. So let's first assume that it is indeed 5 cells long. And we'll see that that causes an immediate contradiction. So 5 cells, it cannot contain a 1. And if it did contain 2, 3, 4, 5, 7, that will mean that this thing right here would not be either 5 or 7, it would be an empty cell, which is a contradiction. So immediately we've dropped out of the case where it is 5 cells long. So it's either 3 or 4. In the meantime, let's first take a look at this 19 over here. And let's make an assumption. Let's assume that this 19 is 4 cages long. 4 cells long. I apologize. I keep mixing those notions up. So, if it is 19 as a 4 cage, if you add 3 to it, and then 12, and then 6, and then 5, add all of these up together, and you get 45. So let's color this 45 with the black color. But let's select all of these in the first box and color them blue. It also sums up to 45. So the blue and the black squares sum up to the same thing. That means that if we subtract the same amount, if we subtract the same cells from both of these groups, the identity between the blue cells and the black cells will continue to hold. And that is precisely what we will do. So the blue ones and the black ones are equal. Since the blue ones are just 2 cells next to each other, their maximal value is 9 and 8. It's 17. Let's check the bottom ones, the black ones. And let's check their minimal value instead. Well, this could be a 1, right? And then this could be a 2. This could be a 3. That's the minimal way to go about it. And this could be a 5 and 6. So 5 plus 6 plus 1 plus 2 plus 3 will make it a 17. However, if this was allowed to be 5 and 6, then this would be free 4. It would now be a 9. So in order to really consider the smallest value of these cells, you need 5 and 7. And 1 plus 2 plus 3 is 6, and 5 and 7 is 12. So the minimal value of the black squares is 18. So the minimal value of the black cells is higher than the maximal value of the blue ones. And they're supposed to be equal, which is, in fact, a contradiction. So we go back, oops, and that means that we've proven that this 19 can only be 3 cells long. All right? Let's keep going. Let's assume that this 21 is indeed 3 cells long. Well, in that case, which values could it take? It could take 4, 8, 9, 5, 7, 9, or 6, 7, 8. Let's assume that it takes 6, 7, 8. Well, 6, 7, 8 means that this would have 6, 8 in it, which means that this would be an empty cell. That's impossible, right? What about 5, 7, 9? Same issue. 5, 7, 9 here means that this would be an empty cell. So it must be 4, 8, 9. And we will fill that in. 2, 5, 6, 7 cannot be there, so this is 4, 8, 9. 4, 8, 9. So that would mean that this is a 6. And if this was a 5, that would be 11, and there would be no path to 15. So that means that this cannot be a 5. And then this is a 2, which sums up to 15. This would be 3 cages long. Now, this means that this is not 6 or 7 anywhere here. And that means that this is not a 5. And that means that nowhere up there is there a 2. Now look at this thing. Where in this row is there a 3 and 4? Obviously it's here, but it can be here, right? Because 8, 9 is here. It's a pair, which means that all of this stuff cannot contain an 8, 9. So that's a 3, 4. And when you have 19 like that, we've proven that it contains only 3 digits, right? Well, that means, and since 19 only contains one small value and 2 larger ones, larger than 5, that means that over here you cannot have 3 or 4 or 5. All right. Furthermore, if this was a 7 or a 6, could that work out? Let me see. So if it's a 7, 6, 6, 7, is there anything here with 6 and 7 together? Nope. Yeah, so this, oops, my bad. So this cannot be a 6. And it cannot be a 7 either, because it would force this to be a 6, 7 pair. But there are no 6, 7 pairs. All right, so since this is a 1, that means that over here cannot be a 1. Oops. Which means that this cannot be a 3. And that is a 4. So then this is a 3. How did this thing become 7 again? So I must have clicked on undo way too many times. So this thing cannot be a 3. Oops, my bad. I selected this thing as well, so this thing cannot be a 3. And now let's keep going. This cannot be a 5, obviously. So, since this is a 4, this cannot be a 4. And that means that this cannot be a 5 because they can make a 9 together. So 6 cannot be anywhere here. And since this is a 7, that means that this is a 5. Now look at this. 5, 1, 4 is not here. So 5, 1, 4 is not here, meaning that you have no way of making a 7. And that is a contradiction. The lowest value here is an 8. So the assumption was that this is a free square, and we managed to use everything we know to make a contradiction. So we're going to go all the way back to that assumption, and that is quite the way back. We'll find it. All right. All right, it was here. So now we know that it has to be 4 long. There is no alternative. And if it is 4 long, we know that it doesn't have a 1 or a 3. So let's kill all of those. And what possible values could it have? Could it be no ones? I probably misclicked on some of these, so let me go through them more carefully. So it cannot have a 1, and it cannot have a 3. All right. There's only 2 possible values. Oh, that's why. I see. It was a 19, and I didn't set it to 21, so 21. So 21 can only have 4 possible values. I saw that they're not adding up to 21. I was like, wait. Okay, so cannot have a 1, cannot have a 3. All right, can it be 2, 5, 6, 8? Nope, because if anywhere here or here it was 2, 5, 6, 8, then this would not be a 6, 8, which is a contradiction. So 2, 5, 6, 8 drops out. Can it be a 2, 4, 7, 8? No, because that would mean that 7 and 8 aren't here, leaving this as a 6, 5. But 6, 5 can never lead to 15. So it has to be 2, 4, 6, 9. We don't actually know if it's this configuration or if it's this configuration, but it's enough that we know that a 6 is somewhere there, that we know that 6 is not here. And that finally lets us put in the first digit. This is an 8. And now we see immediately that this is a free square. So this cannot be a 7, this must be a 5, and then this is a 2. And then we see that this is a 4 square indeed. We see where it ends up being. And we know that it's a 2, 4, 6, 9, so a 7 isn't here. So the 7 is here. Perfect. And we see that this is a part of the 13. It's 3 long. And indeed, we see that the 18 does not go to this side because there's a barrier here. And obviously cannot go up or to the right. So that means that it's only 3 digits long. Let's try filling that in. 18. 3 digits long. Oops. It does not contain an 8 or a 9. Well, it's only 5, 6, 7. So, cannot be a 1 or 3 or 4. And this is a pair, making this a 7. So, let's fill this in. So, 5 and 6 cannot be there. All right. Let's check the 6, 9 first, I suppose. It's been staring at me for a while, and I want to get rid of it. So 6 and 9 cannot be here. All right, perfect. Which means that a free cannot be here because there is no 6. And that means that this thing is 4, 5. So 4 and 5 cannot be there, which makes this a free 2, 1, 5, 4. And now I see we haven't cleared up the 19 again, so let's do that in a bit. There's more stuff to do that's quicker. So since 5 is here, it cannot be up there with the 7, but the 7 isn't there anyway. But since the 4 is here, it cannot be there with an 8, so that's a free 9 pair. All right, so 3 and 9. Perfect. And then what do we have? 7, 8. Let's try the 19 and see if maybe we can resolve it. Right, so we know it has a 4. We know that it doesn't have a 9, so it must be 7, 8. So this cannot be a 6. So that means that the 7, 8 is a pair, so this cannot be 7, 8, so it has to be a 6. And yeah, it's pretty good. 2, 4, 6, 9, right? That was what it was. So 4, 9 cannot be here, and it cannot be here, meaning that this is a 2, this is a 6. This is therefore 4 and a 5. So 3, 9. All right. So 1, 3. And we've solved the west side. We kind of have to check the other stuff. Can this be a 1? Well, let's look at the 13. 13, free long. There it is. If this is a 1, obviously this is not going to be enough to make 13. So it cannot be a 1. Can it be a free? Nope. Same issue. What about a 7? That's interesting. So if it's a 7, the only way, let's gray out all the other ones. The only way to make 13 with a 7 is if you have 1, 5 or 2, 4, which we don't. So that doesn't work. All right. Let's keep going. We see that there is a 7 here, which we didn't notice before. And that means that this thing goes like this. It's a 14, which means that 7 plus 14 plus 10. So this is 14 as well. These squares that I selected. All right. What else can we do? Is there anything we can do? Yeah, we can. So over here, we know that this is not a 4 and that it's not a 5. It's a 1, 6. So this is not 6 and this is not 6. All right, perfect. So this is actually a honeypot. You can't really reason with it because you can't connect it this way. It could very easily go this way. I think it's really clever because usually in Fog of War, you have all the information that you need to make the next move, right? That's kind of a benefit playing Fog of War. But it's very rare to see stuff revealed from Fog that doesn't lead anywhere. It's pretty cool. So let's assume that this 20 is a 4 square. So this is our assumption. Since we said that this is 14, that means that this would be a 6. So 1. Actually, before that, I see something easier. I see this. So this cannot obviously be a 9. It cannot be an 8. Can it be a 6? Nope, that would be a 10 minimum. Can it be a 5? Nope. Can it be a 4? Nope. So 2 free. And now there's two possible scenarios, right? Or here it could be just immediate 8 with 3 and 5, but it could be 3, 4, 1 or 2, 5, 1. And the hints again get this wrong. They forget the case where this is 2, 5, 1, which is not trivial. So let's go back here. Let's assume that this is 4 cages, 4 cells long. If it was, well, that means that this is 14, so this has to be 6. Oops. So 1, 2, 3, 7, 8, 9. That's a 6. So that means that nowhere here is there a 6. But then this is a 1. So there's no 1 over here. But look at this. We said before that this can only be 3 squares long if there's a 1 here. Otherwise, it can only be 2 squares long, making this a 3 and 5. All right. So look at this. This is a 9, and this is then an 8. So this cannot be an 8 or a 9, and because of this 3 here, this cannot be a 3 or a 5. So this is a 2, meaning that there's no 2 here. This is a 7. All right. Now take a look at this 14 over here. What values could it possibly take? So 4, 6, and 7, we're looking for values that don't have these. So it's either 158 or 239. But since 2 and 3 are here, there's no possible way you could fit 239 here, because if this is 2, then 3 would be here, which would cause a contradiction. So you can't cram 239 here without running into problem with this. Therefore, this is 158. So it's not 2, 3, 9. And since this is a 5, that means that there is no 5 here. So this is a 1, 5, 8. All right, let's take a look at this 11 up here. It does not have 1, 5, 2, 3, or an 8. Can this be a 9? Obviously not. So it's a 4, meaning that there's no 4 here, meaning that 4 and 6 aren't there. But take a look at this. That means that this thing has to curl this way, and this must be a 1 in order to make 11. So this must be red, and this must not be 2, 5, 7, and 8. But that means that this thing is confined to only 2 cells. And what is the only way to make a 16 out of 2 cells? Well, it's 7, 9, and 9 is over here. So that's a contradiction. So we go back all the way to the assumption that the 20 square was 4 cells long. Since that assumption is wrong, we now know that it's only 3 cells long. And that means that it cannot have a 1 or a 2 in the cells that we are sure are a part of the cage. So it can be either like this or like this. We're not sure yet. All right. Let's keep going. Let's assume next that indeed there's a 2 here, so that it is in fact 2. This could be a 4 maybe, right? So 2, 4, that's a 6, but there's no way to finish an 8. So this must be 2, 5, 1. So let's assume that that is 2, 5, and then this must be a 1. Well, in that case, let's take a look at what is left of this after we, 1, 2, 5, after we deal with that assumption. So as we said, we will only consider these two possible values. So there is a 5 and a 1 here. So it's the opposite situation of before, because there is no way to fit 1, 5, 8 here without causing a contradiction with these two. So this must be 2, 3, 9. So it cannot be 1, 5, or an 8. And that's why this thing is a 2. Alright, so this thing up here cannot be a 3 or a 9. And once again, can this be an 8? Nope. With a 4, this would be 12. So that's 4. Meaning that 4 isn't anywhere here. So this isn't an 8, this is a 6. So 6 isn't anywhere here. 4, 6, this must be a 1 again. Oops. 2, 5, 7, 8. So look at this. That means 1 is here. But what about this scenario, this situation down here? 3 and 9 aren't there, right? And since 8 is here, that means that 8 isn't anywhere there, which is a 1. So there's a 1 here and a 1 here. That's a contradiction. So we have to go all the way back to the assumption that the first cell in the 8 cage is a 2, because that's not true. So it's not a 2, so it's a 3. And now we can see that it's actually longer than just 2, so this cannot be a 5, it has to be a 4, and this is a 1. And now we can see that this is a part of this. And we can see that this isn't a part of the 20. And since 20 was in fact only 3 cages long, which we've proved, that means that it has no 1 or a 2. So it cannot have 1 or a 2. Alright? So when you click on 1, 1 is either here or here, and in both scenarios, there is no 1 over there. And in fact, there is a 6 here and a 1 here. And that leads us to knowing that this is a part of this complex. Pretty good. And when we click on the 2, that is interesting. That is very interesting. So let me think a bit. 4, okay, we see it. 4, 6. Probably shouldn't rush too much so we don't make any mistakes. That's a 1. And that's the 2s. Let's check the 3s. Well, immediately it's obvious. Well, it's not, actually. Maybe this is 9, too. So I shouldn't rush. Okay. So freeze, 4s, 5s, 6, 7, 8, 9. I think I see it. So basically, could this thing, basically this thing contains the 2, right? Which means that this is the correct one. So we had these 2 possibilities. Since it contains the 2, it must be 2, 3, 9. So it cannot contain an 8 or a 1 or a 5. So 9, 2, 3. Perfect. Which means that this is 8 and 5, and this must be a 7. So this is a 1, 4, 3, 1. So that is 4 and 9, 13. 6, 9, 4, 9. Now I have to be careful. Oh, there's a 2 here. Wow, 2 spotted. Okay, so now we see that I should not rush. There's simpler stuff to do. All right, so now we see that this is a 16, right? So that means that this must be 9, 7. Making this a 2, 4, 3. Could this be an 8? Obviously not, because this is only 2 squares big. So 5 and 6 and 8. And we see that this thing, this square, extends to this now. And to this as well. Alright. What else? Surely something opened up. Yeah, the 8 here, the 2, and 1, and 4. And there's a 4 here. There's a 7 here. 8, 7, 6, 7, 6, 9, 1. Wait, what? 9? Oh, I clicked on the backspace instead of the 1. This is a 5. This is a 6. And now, this is an 8, 9, 7. Let's check the value of this 23. So the 23 has 4, it has a 7 and 9 in it. So can it have a 1? It cannot. Can it have a 3? Yes, but a 4? Nope. So it's 2 and 5. Therefore this is a 2, this is a 5, this is a 3, this is an 8, this is a 5, 8, 2, and that is a marvelous puzzle. Alright, that was quite more difficult than I thought, given its rating. You can see that it really isn't rated that high, but the hints are all wrong. So the 3rd hint and the 6th one, I think, if I didn't forget their indexes, are not correct, and solving the puzzle takes a little bit more effort. Thanks for watching, guys, and if maybe I missed something, please let me know.